beautiful people, and welcome. In this video, we are talking about how to solve radical equations. As always, if I make a mistake, I am human. Let me know where it is, so that way I may correct it and learn from it. So we're going to start off with some steps. Now, these steps, again, as I always say in my videos, these steps are not set in stone. We're going to maybe change them as we do some examples, add to them, remove some stuff. But this is what I've come up in the beginning. So the first thing you're going to do is combine like terms. So let me back up a little bit. Radical equations are the ones with roots. So you're dealing with solving things with square roots, cube roots. You're dealing with rational equations. You're dealing with fractional equations, like x to the 3/2 power. So when you're solving an equation does have an equal sign. So because it has an equal sign, our answer is going to be x equals something, y equals something, a variable equals something. We actually will have equals in our answer, which is different than when we were simplifying expressions. The first thing you want to do is you want to combine like terms if you can. You want to combine radicals if possible. After that, you're going to isolate the radical to one side, constants to the other. Again, that's all combining like terms. I could have simplified steps 1, 2, and 3 in just one statement, but make sure that you get rid of things outside the bubble. If it's in a radical, it's in a bubble. Make sure you be careful with that. Make sure multiplication is king. Addition, subtraction, get rid of it. Again, if it's outside the bubble. After you get rid of it and you have one thing left over, one radical or one bubble to a fractional exponent, you're going to either square both sides, you're going to get rid of that. After that, you're going to have a resulting algebraic equation. Then you simply solve for the variable. The only thing different now is you're going to have to check for extraneous solutions, which means you take your answers, plug it back into your original equation, make sure that it works. If it does not, that answer is extraneous and we omit it from our final solution. All right, let's go ahead and jump into example number 1. Let me actually zoom out just a little bit. Go ahead and pause this video, write down these steps if you wish, and make sure you have them if you are in my class, as I will be referring to them always. All right, example number 1. All right, for example number 1, I have 2 plus the square root of x plus 10 is equal to x. So I do see x's on both sides. However, this is the bubble I'm referring to. Anything with the square root, cube root, doesn't matter. It's in a bubble. So we want to keep it in a bubble. Now, outside my bubble is I have this 2. This 2 is a positive bubble. So I'm going to subtract 2 from both sides. Here I have is the square root of x plus 10 left over. And here I have x minus 2 on this side. Now that we have an isolated radical right here, we have an isolated radical. We're moving on to square or cube both sides, depending. Well, what is our root? Our root here for square root is a 2. So I need to get rid of this radical. I'm going to square both sides. This is where the mistakes typically happen, so be careful. I'm going to say write out the bubbles, because you cannot unofficially distribute that to x as the exponent. Because of this pesky minus, remember, multiplication is king. This is not multiplication. You cannot do what you want to do. You want to, FOIL in that 2. You can't. You have to write out the bubble. And it's easy to write out the bubble. This one cancel out. We have x plus 10 left over here. And this is x minus 2 times x minus 2. So you can use the box method or you can FOIL out, up to you. I'm going to choose to FOIL. So I have x squared minus 2x minus 2x plus 4. So what do I have here? I have x plus 10 equals to x squared minus 4x plus 4. There should not be an x there. There should be just a minus 4 or a plus 4. There it goes. Okay, so then what do? Well, now we solve as we usually should. Here is I'm going to bring it back up. So when you're solving the resulting equation for the variable, if you have an exponent on your variable, move everything to one side, and set equal to 0, factor. It's going to be easier for you that way. So when we're here, we're going to set it equal to 0 by moving everything over to the other side. So I'm going to subtract an x, and I'm just going to subtract 10. So I have left over 0 is equal to x squared minus 5x minus, what is this, 6. I'm going to factor. I should have left myself more room, but I guess I didn't. That's okay. We'll make it work. So I have two things that are multiplying to negative 6, but when I add them, give me 5. That means I have negative 6 and a positive 1. Now that we're going to be factoring, we're still solving. We still need to, oh, you guys can't see that. We still need to solve for x. So once you're here, you're going to solve for your zeros, just like we did when we initially found our x-intercepts. You're going to set each bubble equal to 0. You're going to solve, which x is equal to 6 and x is equal to negative 1. Now, these are not my final answers because I don't know if I have extraneous solutions. So I'm going to take each one, I'm going to plug it back into my original and see if it works. So I have a 6. 6 plus 10, that's 16. The square root of 16 is 4. 4 plus 2 is 6. And x, I said, is 6. So 6 works. That gives a little check mark down below. You can't see it, but I put a little check mark. Trying negative 1. Negative 1 plus 10, that's 9. 9 square rooted is 3. Yes, I can do that. 9 square rooted is 3. 3 plus 2 is 5. 5 does not equal to negative 1. So let's go ahead and write this one out just so you can see it, because it actually didn't work. So I have a negative 1 plus 10 is equal to negative 1. Again, x's. This is the square root of 9 plus 2, which means I have 2 plus 3 does not, in fact, equal 1. Therefore, when we're back down here, this one is extraneous. So we omit it. So what is our answer? Our answer is x equals 6 only. All right, let's do a few more examples. There we go. Example number 2 actually does not have a radical. It does have a rational exponent. That's okay. We're still going to do the same thing. This right here is in a bubble. We're going to undo what's outside the bubble first. Get rid of the addition subtraction. So I'm going to add 2 to both sides. This is x plus 5 to the 1/2 power, and this is 3. Now you have options here. You can either rewrite it as a radical if you'd like to see the whole square root of x plus 5 and then square both sides, or you can see that you need a 1 as an exponent because you need to get rid of it and multiply both sides, well, not multiply both sides, but raise both sides to the power of 2. It's your choice. You're doing the exact same thing, just different. I choose to rewrite it. For some reason, in my mind, when I see the radical, I know a lot more what's happening than when I see the fractional exponent. So when I square both sides, that goes away. I have x plus 5 is equal to 9. I'm going to subtract 5 both sides. So I have x is equal to 4. Double check my answer. Make sure it gives me what I need. 4 plus 5 to the 1/2 power minus 2 is equal to 1. Let's check. 4 plus 5, that's 9. That's the square root of 9 minus 2. 3 minus 2 is, in fact, equal to 1. So therefore, this is one of our solutions. Well, the only solution, because we only had x here. Notice that x did not have an exponent, so I did not move everything over to one side. I left it there. All right, let's move on to example number 3. Again, this is in a bubble. Keep it in a bubble. We need to undo what's outside the bubble first. So I have 7, 5, 6, 7, 2, negative 2. So I have cube root of x plus 2. This is the first one that we have a cube root of. That's okay. It's the same thing. So now instead of squaring both sides, I'm going to take the cube root of both sides. So I have x plus 2 is equal to negative 2 cubed. That will give me a negative answer. 2 cubed is 8. I'm going to subtract 2 both sides. X is equal to negative 10. Double checking my work, plugging it back in. So I have cube root of negative 10 plus 2 plus 7 is equal to 5. Checking that. Cube root of negative 10 plus 2, that is negative 8. Cube root of that is negative 2. Negative 2 plus 7 is in fact equal to 5. So it works out. Negative 10 is in fact our answer. All right, let's go ahead and go to the next one. Now this here, I kind of started to do the bubble again. This is a square root. Oh, look at here that we have both x's on both sides. I don't have a 2. So I have a 2 here. There's no other constants that I need to do. So what I'm going to do is I'm going to go ahead and just get rid. This is by itself, so I'm going to get rid of it by squaring both sides. So I have 4 minus x is equal to, write this out. I have x minus 2 times x minus 2. Make sure that you're writing this out. If you don't write it out, you're going to make a hiccup. You're going to do silly mistakes. Don't make silly mistakes. This is not distributing that 2. Don't do it. Rewrite it, and it will save you lots of tears later. All right, FOIL this out. So we have x squared minus 4x plus 4, and that's equal to 4 minus x. Did we do this one already? This seems familiar. Maybe something very similar. So I'm going to subtract 4 and add x to both sides. And the reason I'm doing it is because I'm noticing there's an exponent on my variable, and I have two terms with a different amount of variables. For example, I have an x squared here, and I have a 4x. If both of them had the x squares on them, then I could combine them like terms, but they are not like terms since one of them is squared and one of them is not. That means I'm going to have to factor. These go away. I have 0 is equal to, you know what, I am having deja vu because now I'm running out of space here, and I think that happened in a previous example as well. So x squared minus 3x, and that's it. Because my 4's cancel out, and we have combined like terms, so that is, ooh, check this out. This means I have a binomial with an exponent of 2. However, I'm noticing I have an x and an x. We're going to factor out that x. I have an x minus 3 left over. So I have 0 equals x times x minus 3, which means, how are these attached? These are attached by multiplication. Both of them are in bubbles. So again, you can ask yourself that question, what does x have to be in order for this to be 0? Or you can simply set each bubble equal to 0 and solve for 0 and solve for the x value. In this case, x is 0. There's nothing to solve. You are done. X is equal to 0. Here, you're going to add 3 to both sides. So x is equal to positive 3. Now again, we're not quite done because we have to plug it back into the original equation to make sure it works. 0 is a little easier to solve. If I plug in 0 here, that is the square root of 4. Square root of 4 is simply 4. Haha, did I say that? Square root of 4 is simply 2. So now here, we have, what do we have? We have 0, negative 2, negative 2. Ooh. Oh, you know what? I tripped myself up because I thought that squared was the original. It's not. This is the original. So be careful. This is the original. So when I plug it in, here's 0. Square root of 4 is 2. Here's a 0. 2 is not equal to negative 2. So therefore, 0 does not work. Let's try 3. 4 minus 3 is 1. Square root of 1 is 1. 3 minus 2 is 1, so 3 does work, and so our answer is positive 3 only. Alrighty, let's go ahead and do one last one before we wrap it up. Now, this one is considered a challenge problem, and I'll tell you why. Do you see how we have a root here, a square root, and we have a square root here? However, these are not being multiplied. Again, multiplication is king. Anytime you see addition or subtraction, you guys, you should be like, oh, shucks, darn it. It's not good. Addition and subtraction after grade school does not simplify your life. It complicates it. All right. So when you have something like this and you're adding these two radicals together, however, you can't really add these two radicals together. Separate them out. So we're going to have a square root of 2 times y plus 5, and we're going to have a 3 minus square root of 2y. The reason I did that is because now that I have a root on both sides, I can then square both sides to get rid of the root. We're trying to undo the root. We're trying to get the y. We're trying to get inside of that root. So therefore, I have 2y plus 5 left over. This, don't do it. Anytime you see addition or subtraction, stop. You are not unofficially distributing that. You are writing this bubble out twice, meaning you have 3 minus root 2y times 3 minus root 2y. Do the box method to multiply this out. If you want to do the FOIL method, you can. Just be careful. This is a root. And it's a negative on the outside. So here I have 9. Here I have negative 3 root 2y. Here I have negative 3 root 2y. And here I have, negative and a negative makes a positive. So here I just simply have 2y. So here I have 2y plus 5 is equal to 9 minus 6 root 2y, because I added these together. I have 3 of these and 3 of these, meaning I have 6 total, plus 2y outside of the bubble. Now I have a 2y here, 2y here. This is where you're going to start combining like terms. You have only one radical, so we're going to undo that. We're going to get rid of everything else. You're going to see things start to cancel out. This 9 is in a bubble by itself. This 6 is the one with the negative. So we're going to subtract 9 both sides. So I have negative 4 is equal to negative 6 root 2y. Again, we're still not done. So how are these two things attached? We got to get rid of it. So we're going to divide by negative 6. So I have root 2y is equal to a positive 2/3. And we're still not done. This is why this is a challenge problem. Now that I am by myself here with my square root, I'm going to square both sides. This gives me 2y. Again, if it helps to write it out, write it out. This is 2/3 times 2/3, which means I have 4/9 is equal to 2y. I'm going to divide by 2, which is the same thing as multiplying by 1/2. So if you want to multiply by 1/2 here to make your life easier, do that. So y is equal to 9 times 2 is 18. 4/18. Now, 4/18 we still can't simplify. So 2 goes into 4 twice, 2 goes into 18 9 times. So this is our potential answer. We just need to double check and plug it back into the original. So you know what, you guys, just to save time on the video, I am just going to tell you that this does end up working. I just wanted to wrap up this video, make it a little bit shorter for you guys. So when you take this 2/9, plug it back into the original equation, it does end up equaling to 3. Therefore, we do have a solution of 2/9. All right, beautiful people, thank you so much for watching, and I'll see you in my next video. Bye.